and I'm in 6th grade at the Expedition School. I'm here to show you our solar system river walk. First we have the sun. The sun is the center of our solar system, and on average it's 5,505 degrees Celsius, so I'd be careful how close you get. So, the sun is the center of our solar system. Everything revolves around the sun. All our inner planets, all our gas planets, all of the asteroid belt, everything out for a very long time. And the layer of the sun got everything that you can think of. It's got the core, the radiative zone, the convection zone, the photosphere, the chromosphere, the transition region, the corona, and the solar wind. It's like an onion. So, the group that did the sun, we, for extra credit, decided to make a chart of how many of each planet will fit into the sun. So we had the planet radius, planet volume, and how many of that planet will fit in the sun. So for things like Jupiter, it's only about 924 of Jupiter into the sun. But for Mercury, it's 23,239,122. That's a lot of Mercuries. But down the road to Mercury, let's go. Here we have Mercury. Mercury's really tiny. It's about the size of the moon, actually. It's cold because it's cold on the side that's away from the sun, and really, 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 really hot on the side that's to the sun. So, Mercury is really actually very long on the scale of humans, but it's really small on the scale of the solar system. But even on the scale of the solar system, we couldn't represent the entire size of Mercury, so we had to put the solar system to scale. Our solar system scale for distance is where there's about 5 meters from the sun to Mercury. No, there are not actually only 5 meters from the sun to Mercury. But then some of the planets like the moon, Pluto, and Mercury would be nearly microscopic. So we had to make the scale of the planets much larger. So what we did is we had to half it. We had to half the scale of the distance to do the planets. So the scale of the planets is 20 times that of the scale of the distance. Next, we have Venus. Venus is very gassy. It's Earth's evil twin. It's just about the exact same size of Earth as Earth. Venus got its name from the Roman goddess Venus. It got the name for her beauty and brightness. Next, right before we hit Earth, we have the Hale-Bopp comet. On April 1997, Hale-Bopp reached the closest distance to the sun, at a distance just less than the Earth-Sun distance. By then, Hale-Bopp was much brighter than any comet. And it had crazy, crazy long tails. Look at this. These are the length of Hale-Bopp's tails. This is just about past Mercury. That's a lot of tail. Also, this is the tiniest tail, but it still reaches all the way to Venus, so it's a lot of tail for a tiny tail. And then, of course, we have Earth. Awesome Earth. You know everything about that. You live on it. hopefully. And right next to Earth is the moon. So really the moon is very far away from Earth. But on our scale, the moon stake would go right here. Just about that far away from Earth. But come on, you don't want to miss the show on Mars. Welcome to Mars, you have arrived. Mars, at least according to NASA scientists, is probably the most likely planet in our solar system of life, other than Earth, of course. And look, you see this straw here? That's the size of Mars on our scale. Now, and that's 20 times the scale for distance. Imagine how small it would be if it was the same size as distance. Come on! We gotta get to the asteroid belt. You have left the rocky planets. Welcome to the asteroid belt. Look out for the asteroids. We couldn't just have one stake for the asteroid belt because the asteroid belt is so huge. It has to have a beginning, a middle, and an end. The asteroid belt is really huge. It's literally gigantic. Come on, we're almost in the middle. Well, that was the middle. But here's the end of the asteroid belt. Come on. We have to enter the gas planets. You made it! These are the gas planets. Or the gas giants. First off, we have the mighty Jupiter, the biggest planet in our solar system. It's huge, and it has the legend red spot. And just to show how much of a difference there is between the rocky planets and the gas giants, this is the scale of Jupiter, this pipe cleaner here. And if you can remember, Mars was only about this big. Now, imagine how many Marses fit into Jupiter. That's a lot of Mars. Now we're heading towards Saturn, but it's going to take a very long time. Because out here in the gas giants, they're very far apart. Not real close together like the rocky planets. Oh, here's Hale-Bopp again. This is the distance when it was first this was the distance it was at when it was first discovered from Earth. Don't worry, we're almost there. We will eventually reach Saturn. Here we are at the mighty Saturn. Saturn has the largest ring system in our solar system. It's huge, but not quite as big as Jupiter. On the other side, we have the other classes on Saturn. Saturn and Jupiter help guard Earth from lots of deadly meteors. Without these planets, we probably would have blown up by now. If you look way out there, you can't even see Uranus. This is going to take a while. And this is on an incredibly small scale for the planets. Imagine what it'd be like in a spaceship. There it is, you can just barely start to see it now. Here's Uranus. Uranus and Neptune and Pluto are all so far away that we have barely any information on them. Supposedly, Uranus was once long ago hit by a giant asteroid that knocked its axis sideways. So the ring systems go up and down from pole to pole instead of along with the axis. It's got all 27 moons? Wow. I'd hate to have that many moons. Okay, now we have to embark on a long, long journey to Neptune. Neptune is so far away that if you took off your spacesuit on Neptune, you'd automatically freeze into a giant block of ice. Don't worry, we will eventually reach it. See? There it is. NASA scientists have had a very difficult time finding images of Uranus and Neptune. So the kids who did this had to draw them. This is Neptune. Uranus and Neptune are very similar planets. They're both made up of ammonia, rock, water, metal, and methane. Their weather and atmosphere are also the same. Wind speeds are up to 100 miles an hour, and they have hurricane-like storms. The atmosphere is mostly made up of a gas called hydrogen. Okay, we're almost at the end of the solar system. Pluto should be just right up here. We're almost there. Almost to the very edge of our solar system. You have left the solar system. With so much new knowledge, what will you do now? You've walked really far to get to Pluto. This is the dwarf planet named Pluto. Pluto is the closest dwarf planet to the Sun. It's approximately 149,597,871 kilometers away from the Sun. Well, that's our solar system for you. Again, I'm Emmeline from 6th grade in the Expedition School. Thank you for watching.